Hi, I'm Haishi. I'm a Windows Azure technical evangelist, and welcome to Cloud Patterns. Cloud Patterns is a new video series we are putting together that focuses on proven patterns and common practices you can use on Windows Azure, especially Windows Azure Cloud Services. So before I talk about what the show is about, let me tell you what the show is not about. So it's not about the cutting edge stuff. We have a separate show, Cloud Cover Show, where you can get the news of latest development of Windows Azure. And it's not about specific techniques as well. For instance, for Service Bus, we have a show from Clemens Wester focusing on Service Bus. We also have a Web TV, which is mostly focused on web technologies. So in here, what we are mostly interested in share common practices and experiences that we can collect from inside Microsoft and outside Microsoft. And we want to share that experience to the community so that when you encounter the similar problems or scenarios, you can apply this knowledge or get some guidance or at least some additional source of thinking. So the format of the episodes in this series is really flexible. We'll have some webcasts, we'll have some studio recording like this one, and we'll also have some field interviews. And this is actually the first studio recording we are doing for this series. And I'm very happy to have Abhishek Lal, the senior program manager from the Service Bus team, to talk about the Service Bus. So welcome to the series.
Thank you.
So as we know, Service Bus has been a very important application service ever since the beginning of Windows Azure. And we've seen very steady adoption of Service Bus over the past few years.
That's right.
And here, I have to mention again that Halo 4 uses Service Bus as a backend service. I'm a big fan of Halo 4 and a big fan of Service Bus, so you guys got double points from me.
Thank you.
So, I guess over the years, we've also observed some confusion when people try to use different capabilities of Service Bus. And as I understand here, you will tell us when to pick which technology in your scenario and make sure you have a successful implementation of Service Bus.
Absolutely. Thank you, Hashi. So, working with a bunch of customers till now, we see very, very different kinds of needs and requirements come up for different services or clients or devices, what the end-to-end application experience that customers are looking for. And within this, Service Bus provides you a wide range of options of how to connect these services and these applications and these devices. So picking the right one can be a very, very key towards having a successful sort of experience and deployment in, as you go along. So Hashi and I were discussing, and we thought we'll just walk through some of the basic scenarios which we see different folks try, and how they, what are the different choices which they have to make.
Right.
So, if I can draw.
Yeah,
so in
sure.
terms of the basic Service Bus value prop, you have the Windows Azure Cloud Services available here. Service Bus is a PaaS service. Let's start off with a scenario where you have something running locally, on-premise. So this is your own data center, and you have some kind of service running over here. Now, this service may either want to talk to something hosted in the cloud, or the service may want to talk to another service which is hosted somewhere else. Let's call this another data center with another service running. When you say two services need to talk to each other, that generally is a very synchronous kind of communication. That's a place where you might actually be making a request here and a response here in a synchronous way. So to expose that, you could use our relay functionality, the Service Bus relay in the cloud, and use to connect both of these services in there.
Yeah.
Now, this is a very connected experience. What it means is, let's say if this service goes unavailable, then all requests to this service will fail, even though they're going through the service bus in there. So it's a very coupled pattern of two services.
So can I read relay here?
Yeah, absolutely.
Relay, let's put it on the left.
Right. So with the relay, what we generally see is folks are trying to achieve location transparency, that you could have this particular service hosted at any customer site.
Right.
And still you're able to work with it in a synchronous way and be able to provide your functionality from your own data center. If you're an ISV, and let's say you want to build a local solution where the customer data is in their premise and in their data center, and then you want it to talk to your data center, be it in the cloud or be it here, Relay makes for a terrific option there. And again, some of the services, like what you'll generally find here is that there's a fairly strict firewall.
Yeah, definitely.
Right? And you don't want to open any inbound connections towards this data center. And the way Service Bus will help you is we will make an outbound connection. And thereby, you don't have to open any inbound ports, and then you can do two-way communication on that channel.
Okay.
So in that, we see that happen.
Okay.
Now, as people adopt cloud patterns more and more, or if you are working across application boundaries, what you will see is these two services may be better decoupled. They might want to talk to each other, but in a decoupled fashion.
Yeah.
And the moment you do that, you would bring in something like a queue.
Yes.
Right? So in the queue pattern, slightly different way to think about is when this service enqueues a message, note how the endpoint is the bus.
Yeah.
It's just the service bus. So what you're doing is you're sending a request or a message or however it's packaged up to the bus. And that's your endpoint.
Yeah.
And then this particular service can pull that message and process it. So again, it is talking to service bus.
Yeah.
Now, if you think about request and response, it is still very much possible. You put the request there, you get here, you put the response here, you get there. So you can still achieve request response here.
Yeah.
The exact same pattern as the previous one.
Yeah.
But note, it is decoupled.
Yeah.
So what this means is, today if this service goes away,
Yeah.
let's say if this service is unavailable, your clients will still be able to queue messages. They will just not see responses come in.
Right.
So it's a key decision for you in terms of what is the application pattern that you're looking for.
Yeah.
If you're looking for a pattern where you should be able to enqueue requests and dequeue them much later, then you have to use queues.
Okay.
If you want the request to go in and come out very, very close to each other, then queues and relay both are options. You can absolutely use queues and you can absolutely use relays.
Okay.
Now with the queuing pattern, you get a couple of unique advantages, which depending on your applications are valid or not. One key thing which we give you is transactional consistency. So for example, if you take a message and you put it into the queue, the moment the call returns, it's acknowledged, that is a durably stored message.
Right.
So at that point, you can be absolutely sure that whenever a receiver comes along, that message will be available to them. You will not lose that data.
Right.
So now if you start thinking of services which are doing banking transactions, or they're doing something which is like order submission, this becomes very, very critical.
Oh, that's right.
Right?
Yeah.
That you absolutely want to submit an order and not lose the customer's order.
Yeah.
In
We don't want to lose money.
Don't want to lose. No one wants to lose money. So in that sense, the durability of the queue is really an advantage. At the same time, let's say if you were connecting to your customer's website and you were sharing with them, let's say, latest updates or sort of an activity feed of what is going on in terms of a product launch or something like that. In that scenario, each message may not be as critical.
Yeah.
It may not be required to be durably stored. So you can still use the queuing pattern, but you can do a little bit of more robustness in terms of availability by saying, hey, instead of one, maybe I will use several queues. Right?
Okay.
The reason being, if strong order guarantee is not important to you, then anyway you should shard across queues. even if strong order guarantee is important to you, then you can use queues with sessions in them.
Okay.
So in that way, you can apply different techniques to improve availability and improve throughput in terms of your system.
Okay.
So again, the way the system scales is it scales out through number of queues.
Okay. So for multiple queues, I use multiple queues mostly to increase the throughput as well to have some fallback or
Correct. More availability.
Availability. Okay.
Right.
Okay.
So that would be a common pattern in terms of using multiple queues in there.
Okay.
Now, let's talk about a little bit about these characteristics of applications and services which are using these two different patterns. Let's say
actually, let's read the other pattern over there.
Oh yeah. So let's say
I have
queues.
relay, yes, queues. So then we can start to lay out some of the typical applications we can build in
Correct.
each segment.
And we can walk through those ones.
Yeah.
So when we just talked about relay and queues, I think one we can say is strongly coupled,
Okay.
right?
Let me write
So just
down
say
this way.
coupled,
Okay.
and I'm going to say decoupled. So here's a key difference which you will see between relay and queues, which is in there.
Yeah.
The other part I will say is that load balancing we support in both of these scenarios.
Right.
So that's also an interesting part to understand. As you can imagine, that the client side of the service or the server side can both scale independently, right? And this becomes more and more relevant when maybe one or more of your services are actually hosted in the cloud, because cloud services inherently are more scalable in there. So if you are in the cloud and let's say you're using a relay pattern, or let's say you're using a queue pattern,
Okay.
you can have multiple receivers, multiple instances of your worker roles, all competing for messages onto the queue.
Okay.
And the same way as you can have multiple roles sending into the particular queue.
Okay.
Right? When you have this kind of model, very soon you'll realize the need of sharding
Yeah.
or of addressing different roles in terms of these items.
Yeah.
So very, very soon, once you start increasing the number of clients and services, you will need topics and subscriptions.
Yeah.
So that's the pub-sub pattern which we support. Now, the way to look at a topic and subscription is one queue sort of endpoint.
Yeah.
Sending a message to a queue is symmetric to sending a message to a topic. Similar APIs, similar performance and everything. And then each subscription to that is its own queue. So now you can have one receiver go pull from here, one receiver go pull from here, one receiver go pull from here, and you can imagine you have a logging service, you have an audit service, and you have, let's say, a fulfillment service. All of them have different views of their messages. This can be running as fast as it can, this may be taken offline for a day and its queue will grow. All of them will have messages separately.
Yeah. Excellent.
So again, this is also decoupled. So I'll put queues and topics both in this bucket,
Okay.
where it is one-to-many or one-to-one communication, but in a decoupled fashion.
Right.
Even in relay, you can have one-to-many by using the net event relay or any of those. So in that way also you can send one message out to several receivers.
So basically you can have multiple listeners to the same endpoint.
Correct, correct. Well, you can have multiple listeners to the same endpoint, both for either load balancing or for one message to many messages. So both of those are supported. Now a key difference in terms of these two, what you need to know is how many receivers you will be doing. By the inherent coupled nature of relay, the way we load balance is one endpoint can have up to 25 concurrent listeners. So that's our scale point. If you look at queues, we allow up to 100 concurrent or topics, you can have up to 100 concurrent receivers on each subscription, or you can have up to 100 concurrent senders to a topic, that kind of scale. So definitely look at your numbers of how many clients and how many services you need to connect, and keep that in mind.
And if I want more capabilities or more throughputs, I can just scale out my design.
Correct. For every design, it's always scaling out to the number of entities.
Okay.
So here, relay, you will create more relay endpoints, which is more of your services, creating a new relay endpoint. And then each instance of that service can have up to 25 listeners, 25 senders. In queues and topics, you'll either create more queues or more topics. And each of the topic will have subscription equivalent. So that's a little bit in terms of what you see, the basic coupled decoupled pattern and scaling out. Another big difference which we see is about latency. So in latency, the characteristics which you see between these two are slightly different.
Okay.
From a queue perspective, if you enqueue a message to a queue and then you dequeue it from the other end, we're looking at probably about 150 odd milliseconds end to end, or 200 milliseconds end to end. Whereas in a relay, that would be much less because there is no durable store in between.
Right.
So there is no storage system, subsystem that we have to interact with. So really look at your application closely, and if the messages going through are of the type where it's more an event feed and you don't need the durability in there, then consider relay as one of the key patterns. Whereas if more and more you need the message stored, and another thing is what are the types of clients which you are going to be using. So if you want the message stored, but let's say you want a mobile device to go consume that message, and let's say you have to use REST API for that, or if you are using it from a web browser, and then you need your sort of IIS system to pull from it. So you have different APIs and protocols which are available.
Okay. So for the performance, let's write something down. What do we write the different performance expectation, or the
I think
real
you can write
time
down,
versus
so we should say that if you want real time, then that would really come to a relay scenario. And if you want, again, this would be more the decoupled sort of aspect, then you can use queues and topics.
Okay.
So I'll say it's something to the approximation of about 200 milliseconds, right?
Okay.
That's the kind of delay which you're looking at. And relay would be much faster than that. So depending, and now 200 milliseconds for a human interaction is real time. So that's why.
And I guess in some decoupled scenarios, I don't really care how fast the message was processed.
That's right.
Like I submit the order will be handled in days. Right?
In days, or hours, minutes, whichever that is. So that absolutely works.
Okay.
The one other thing which we are seeing now, and this we've now added recently in preview in Service Bus, is that a lot of these cloud services want to interact with mobile devices.
Definitely.
Right? That you really have at the end either a Win8 tablet, or you have a phone, say iOS or Windows phone, you have some kind of device.
It's funny you put them together.
I don't mean in the same. I'll just call it a phone.
Okay. Yeah.
That's it. So you have a phone or a tablet, which at the end is what you want to communicate with.
Yeah.
So another key feature which we've recently added is the ability to push a notification to any of these. And that's another scenario where you want the app or these applications are not always running, and you want to send a message to either wake up the app or just to update something locally on the app. iPhones have badges, or Windows 8 has tiles, or Windows Phone has tiles, all of them have tiles. So if you want to directly update that tile, then you can now send a message directly to this device.
Excellent.
And that particular pattern, I don't know if it's a good representation, but I'll call this a hub.
Okay.
Is a notification hub.
I see.
And the way it works is a device will directly register to a hub, and a hub can support all the different device types. Today we have support for Windows 8, Windows Phone, both 7 and 8, as well as iOS. That is available today. So they register directly with the hub. And then you can just enqueue a message for this hub and again achieve pub-sub kind of scenarios where you're able to get a badge update, maybe a tile update, or a message directly, just a raw message going to these devices. We will interface with the notification services of these hardware providers and directly send that message to the device for you.
So in terms of the message senders, I'm just sending a message as if I'm sending to a regular queue?
Absolutely. So the format of the message can be the same. You can just send a notification message. What we also allow you is a lot of rich capability in terms of templates as well as tags to say which devices do you want to get the message or not. So again, like I said, it's a very rich pub-sub system in there. From a pattern perspective, what I wanted to call out was if you have very large number of devices and notifications is a key, then rather than looking at any of these two patterns, notification hubs is the right pattern to sort of look at. For those devices to get pushed, notifications pushed to them in terms of directly.
So this is a one-way push to the clients, but it's a very highly scalable and you got it out of the box.
Very, very low latency, highly scalable, and then the other part is you don't have to deal with the APIs and differences between these providers which do push notifications. All you do is a single message in, and all the recipients who are currently listening for that one endpoint is what they will get.
Cool, excellent.
In there. So that's one other sort of scenario which we see customers come up and have, and I think now with notification hubs out there, that's another pattern which we'll be able to address.
Okay, cool. So now we have relay, the queue and topics, and the push pattern.
Absolutely.
Okay.
So those are the sort of the main scenarios which we see customers come in. The other aspect I just wanted to touch on a little bit is about fixed topology versus variable topology. So what happens in a lot of coupled systems, right? You will have very, very fixed endpoints because these things are strongly coupled, they don't change per se. Whereas in decoupled systems, you could have the ability that you can have a queue on which different types of listeners could connect. So one way to think about this, and I think it captures it well, is how long does the message live? What's the TTL of the message in there? In a notification hub scenario, you can see that the message lifetime is ephemeral, right? The message comes in, it's pushed out as a notification, it really doesn't live. In decoupled scenarios, if you're doing eventing, you can do much smaller TTLs, right? You can do decoupled eventing. But in that case, if let's say the storage subsystem is unavailable for 10 seconds, then the event may no longer be useful after 10 seconds. So in that case, you can use much smaller TTLs when you're using a decoupled scenario.
It's not relevant anymore.
It's not relevant anymore. So you really don't have the need in terms of receiving that message. Whereas in a coupled scenario, the TTL is almost next to nothing because either the call goes through or the call is sent back. So there is no TTL in terms of that.
Let's put this on. I read the very little TTL here. I guess nobody can see this.
Okay, I'm going to put a big TTL for much larger time to live for messages. And for hubs, I think you're again right. There is actually a very, very small TTL.
We're starting with really small fonts.
Very nice. So these are the main patterns which we see customers come in. In terms of devices, when I talked about services, Relay today works with WCF. Services. So if you have WCF services, Relay is a great option to think about. We also have bindings, that is if you have WCF code which connect you to topics and subscriptions. So it's just a programming model choice kind of thing. You can use the same programming model and run it against topics. You can have web clients if you use simple web HTTP to talk to the services which you have, the WCF services. On this side, we have our own .NET client library, which uses a very native high-performance protocol to talk to different clients, between the clients and the service. And we have a REST API. So that gives us a really broad sort of a platform reach where you can just, again, make a simple REST call. It can be NQ, DQ, and get all that particular value out of that. So again, protocols and programming languages.
Let's put this down. So this I can use the WCF
Right.
or the web client. So basically, this is go through the standard HTTP binding. for the
Correct. You can
WCF.
use the HTTP bindings
Yeah.
for WCF.
Okay.
Here you can programming model wise, you can use .NET,
Mhm.
or that uses our own sort of native TCP based protocol,
Mhm.
or otherwise you can
Oh, the
use
REST
REST
API.
APIs,
Okay.
which use the HTTP protocol.
Cool.
So you have all those options between those.
Mhm.
And again, from a hub perspective, the only channel is sending a message to that. And again, both .NET and REST are supported here in
Cool.
terms of the message sent.
Mhm.
scenario.
Okay. So that's all we are going to talk about.
Yeah, so these are the key things which we
Okay.
wanted to call out in terms of when customers are thinking about different message lifetimes, how many clients will they need to be connecting, and whether the system is truly a decoupling or is it a very connected coupled system.
Okay. So how about this? Next, we will list out a couple of applications
Right.
as samples that we can just map this into a real scenarios.
Absolutely, I
Okay.
think that's a great idea.
Yeah.
So let's say for relay, you could say one of the key scenarios which we see is database access,
Database access.
right? So you've got database on your premise or in the cloud, wherever.
Yeah.
You want to make a call, you want to get a list of items, you want
Yeah.
to get an inventory list, get
Yeah.
it right now and display it.
Yeah.
That's what you would
So basically,
use
I want to solve the connectivity issue to the database.
to the database.
Yes.
And connectivity as well as authorization and separation in terms of you have location separation.
I
Right?
see.
You,
Yeah.
you have it written some other boundary, whereas this is
See, in this
some
case,
other
I
boundary.
don't really care where my database server is, right? It
That's
can be
right.
on-premise, on cloud, wherever.
Correct.
Yeah.
Correct. So database access
good.
would be a classic scenario there.
Okay.
For the same one, I'd say for queues and topics would be something for load leveling, right? So load leveling is I have two systems which work at different pace. The order submission system
Yeah.
works at one pace where it is just updating orders, putting those in a queue.
Yeah.
The order retrieval and processing system works at a slower pace
Yeah.
in terms of dequeuing those messages. That would be a classic pattern for
Okay.
decoupled,
Okay.
where you need a load level, where you say, hey, the incoming messages really have peaks and troughs. The outgoing messages work at a constant rate.
Yeah.
So the queue size can grow when there's a peak of messages, and the queue size will shrink when there is a trough of messages.
So that's the dynamic topology or scaling you can use in the messaging pattern.
Correct,
Right.
correct.
Okay.
In there. So that is one scenario.
Okay. Let's read more.
Absolutely. Another scenario which we see in terms of relay is something where you can do status monitoring,
Okay.
right? So you want to have live status, the current status of a particular service
Okay.
or a particular entity
Okay.
in there. So you would want that from status monitoring,
Yeah.
where every message is only interesting if it is come if it has come right away
Yeah.
in there.
Yeah.
Another sort of similar kind of scenario is if you have a dashboard and you have all the different services available and you want to see what their status is or ping them and get their status from time to time.
Yeah.
That would be a dashboarding scenario.
Yeah, it makes sense. Those information is bound to a time spatial constraints. So it has to be like real time.
It is real time
Yeah.
information. It
Yeah.
has to be kind of now information.
Yeah.
From a similar way, in terms of a queue, a key scenario can be when you want to do state synchronization, right? So let's say you have state in different places, and you want to all bring it and make it consistent in one place. So sort of eventual consistency, in that way.
Yeah.
So for that, a queue or a topic subscription make a very, very good option, because all the different status updates or state updates can come into the queue,
Yeah.
and then a single processor can process them over time
Yeah.
and make an update in terms of the database and make only a consistent update. So for example, an order system has a classic example where, let's say, the message for the order fulfillment comes first and the payment completion comes next. You don't want to ship the order out
Yeah.
until the payment has been completed,
Definitely, yes.
right?
Yes.
So for that, a queue is an ideal pattern because you keep the message as is in the queue, You don't process it. You see the message, you check, hey, do I have a payment order for this? I don't. Put the message back in the queue. Move on and keep processing other orders. Whereas the moment the payment order comes in, you know you've already got the fulfillment, you let it go in there. So syncing that kind of state or those kinds of workflows, I'll also write workflow here, are very, very important patterns which you will see in terms of this.
Yeah, and you can easily imagine if you want to do the state sync over the relay, it will be really hard.
It will
the
be very
services will be talking to each other to figure out what's the right state.
Correct. And if even one service is down, all your other services are down. Because none of them will be able to process anything if they are all synchronized and coupled up together.
Okay.
So that's one more kind of scenario which you see in there. The other part I'll say is interactive.
Okay.
Right. So anything if you're doing very interactive, which is, let's say, a game like Pong, right? You want to implement Pong, then you would be using something like a relay.
Definitely.
Because at that point, the move has to go through right away.
Right.
You really have to keep both these things in sync. You don't want maybe a 200 millisecond delay between those two. And more important than the delay is if one of the players goes away, it's not available, then the other player continuing doesn't make sense.
Yeah, it doesn't make sense.
Right? It just sort of stops there. Whereas at the same point, I'll put a multiplayer interactive game of poker here.
Good one.
Or chess.
Yeah, good one. Yeah, that's a good
right?
one. Yeah.
So if you have a game like poker or chess, which you want multiple players to play, and there can be a significant time delay between these players, or these players could be connected or disconnected, you might think about doing it using queues. Right? That could be a better way of doing that. Because in that case, when one of the players makes a move, the other player doesn't have to be online to get that move. The player might come back milliseconds later, get connected, and get that move in there. So,
and you may get different people sitting on the same table. People can come and go.
Absolutely, people can come and go, or they could be playing at different times, right? I mean, it could just be you're playing with someone who's in a different time zone, and you make a move in the morning, they make a move in the evening. So a little boring game, but something like that. So again, when you have an interactive scenario, you'd sort of think about using the relay pattern, whereas in a decoupled scenario, you'll think more about queues.
Yeah, I think we've got a fairly good list of typical applications. Let me just do a little bar here, just to where is it? From here.
These are the ones, right?
Okay. Yeah, excellent. So the idea of the sessions like this is just to provide people some kind of source of thinking. If you are dealing with this kind of applications, you can consider if this kind of pattern works for you.
Absolutely, absolutely. And again, there's no sort of black and white decision here. It really depends on what kind of clients are you talking about. Are they web clients talking through a web server? Are they mobile clients talking either directly or in terms of using a backend? Or are these services or just applications running in the cloud or running on your data center? You'll have a lot of different options available to you. What Service Bus is that secret sauce. It's that combination of all these different patterns and features which lets you build applications, either very interactive coupled real-time ones or decoupled long-running stateful workflow kind of applications or mobile notification and sort of interactive in that way applications, all using Windows Azure.
Yeah. Excellent. Yeah, like I just mentioned, Service Bus is a very capable service. We want to get the users to understand for your particular project, you may want to pick and choose different capabilities of Service Bus and make sure the project is successful.
Absolutely.
All right. I think that's all we want to talk about today. And thank you, Abhishek, for coming. This is very helpful.
Hershey. You have folks have questions. There's information on where to reach us.
Yeah,
so absolutely.
Definitely. Yeah, we will post our information to the post, and you can reach us anytime.
Absolutely.
Thank you.
Thank you.